for teachers. So what I've done here is, as you can see, it is on my machine itself. It's a Mac machine. So localhost says that it's in the browser, but it's running locally. The backend is local. Some part of it, but some of it is on Azure. And the knowledge base and Azure search, Azure AI search, and all those things are on Azure. But so basically what you're seeing is some of these items, this is a form which helps in the details that are required by my prompt, which is there in the code. So name of the teacher can be anything that you want, but I just put it for reference. And this POC, proof of concept, primarily is for grade 9, but later on I can build it on for the other grades as well. But just for the reference purpose, or to start with, I just use grade 9. Here what I'm doing is I'm putting lesson topic, and here I picked solar system as the lesson topic, and then desired style of this lesson plan is interactive experiment, and then here the actual thing that you really want from this as a teacher. So as an example, I wanted to discuss about the solar system and all the planets, and also to the sun in the discussion. So basically discuss about sun and all its planets, provide appropriate details. Let's make the change. Details about planets and the sun. And let's run it one more time. Okay, so as you can see, it's a Streamlit app. It was running and now it is done. So let's see the answer that it has created. So these are basically RAG context, retrieve knowledge base context. This is the doc ID, this is the document ID, and these are where the references were. I kept that because this is part of one of the experiments that I was doing. So I kept this as something for myself to make sure that how I'm getting things, even what is the reference it's using from the knowledge base, and how the even output is in JSON. So for teachers, the real output is here. So as you can see, the starts with a hook. Begin the lesson plan by asking student, have you ever wondered why stars sprinkle but planets don't? And why does the sun appear flattened during sunrise and sunset? Show that picture of. So this is all an interactive way of, as I mentioned, it's interactive. So it starts with a hook so that students get hooked to the discussion, make it interesting. Then the explanation, highlighting sun, central star, and its role as a primary source of energy, discuss each planet in detail. So that's the thing. Then activity, divide the class into groups and provide materials such as foam balls, etc., etc. Assessment, ask students to answer the following questions: why don't plants twinkle like stars? So this is for level grade 9. So you can expect the level of details and the questions as well. So then this is references to make sure we know that it is coming from the reliable sources. It's coming from the knowledge base that we have created. So it just helps that it's not hallucinating. Nothing is imaginary. It's whatever is coming, it's coming from the knowledge base, and then based on that, it has built this lesson plan. So that's what the application is about. Now, I would also do one little browser. So let's also discuss about and let me put that query. was part of an experiment. Come on. Okay, let me generate a plan for this. So it's done. Same thing, just like that. Now it has the different items. As you can see, the activity title, how the hook would be to get students interested. So begin the lesson by showing a short video or animation of sand and its fault and its movement during the earthquake. Ask these some interesting questions to get them hooked. Then the explanation, activity. Yeah, so sometimes it comes in a proper format. I still need to fix some of these things. Usually it comes as bulleted points, but sometimes it comes up like this. The formatting is something sometimes I have to fix, but it shows as point number 1, 2, 3, and 4, 5, and then the assessment. So probably is little changes there, or maybe I can run it one more time and the formatting gets better. See, yeah, slightly better, but I was expecting it to be like line items. It is coming not as line items, but yeah, it's better than before. So step 1, draw a straight line down the center of sponges. So this is activity for the children. I mean, it's 9th grade, as I mentioned. So yeah, so that's about the 2 examples which I thought I should share. One was on the solar system, second is on the San Andreas fault. Now quickly about the implementation. So this is the it's a Streamlit app. So you can see this is the section where these are the imports of libraries that I'm using in this app, and these are where I'm getting from the environment variables. I'm not going to show that because it includes the keys and all secret details for this app. So basically, I'm fetching all these details: OpenAI key, endpoint, API version, GPT deployment, embedding deployment, all from the environment file, which is here. I'm not going to open that one, which is quite obviously it includes all the keys and everything. So I'm fetching it from there. Then initialize the OpenAI client. This is when I was using the local KB. It's still in the code, which you can see, and then so on. You can use Azure OpenAI for embedding and the cosine similarity for this purpose, and then the retrieval. This is when you load the KB. When I was using the local one, so that, and then the retrieve, and this is where the prompt comes in. Yeah, so starting with the form. So this is basically the form where you saw Mr. as part of it. So teacher name is Mr. So this is the form, and it's submitted. Then comes the actual prompt. Yeah, so starting with the system prompt, your award winning, blah blah blah, all of CBS learning, blah, this is then comes the user prompt, teacher name, coming from the form that we used. So this helps, the details that we grabbed in the form, they help in building the user prompt with all this context. Lesson topic, desired style, constraints, context, which comes from the context that we built earlier, using only the above context. Using only the above context, right? So don't hallucinate, use the above context, which is here. Generate a lesson plan in the required JSON format. So I can change this if I don't want the JSON format as an output. I can simply say as per the UI requirements or the user experience requirements, whatever they are, I can change that to that. Then these are the this is where the model GPT deployment part comes in, right? The temperature is this, max token is this, right? So this is where you put the system prompt, then the user prompt, and yeah. So if you keep going, yeah. So display, this is a markdown, hook, explanation, activity, and all that you saw. So maybe the formatting that I was seeing earlier, I may have to play a little bit on when it doesn't show up as line items. So I might have to play with that a little bit here. So yeah, that's the application. And the others that you see on this is this is how I build the KB, the knowledge base. And some of these are just for the work that I was doing, that markdown that I created to convert that into PDF. This is retrieving the KB, that was sample KB JSON-L, and the solution. So this is something I was building for myself. And this is upload KB to blob, which is the Azure blob. I have automation which once I let's say build the KB, the knowledge base, I then sync it with the Azure blob. So in the future, I might see the ways where the knowledge base directly builds in the blob, but right now it's the KB first that builds, and then that gets synced with the Azure blob. So you can see that here. This is not a very big file, but it just uploads the file. This is where the client is getting created, connection string, blah blah blah. It is taking all from the environment variables and all from the environment. So back here, yeah. So that's it, and this is the flow, teacher web UI, lesson plan, request, streamlit app query, and this is how this is the backend where it goes to the Azure blob storage. Indexing happens, Azure AI search is in place. Let me see if I can show you those things. This is the KB retrieval, Azure OpenAI embeddings, top and chunks, builds a prompt plus context as we saw in the app.py file, which goes and asks questions to Azure OpenAI GPT model. It builds the lesson plan, post, all these processing happens, and then you see the displayed content. So that's that. Let's see if I can quickly show you. This is where my models are. So this is the OpenAI story block. This is what I was actually looking for. That's what I was looking for. Now, let's go here. This is where the knowledge base is.